Hi, welcome to the Glassworking Shop. Well, it's been a while since the last video and I've been busy doing a whole bunch of stuff. So in today's video, I'm going to be giving an update, a progress report on the prototype glass lathe project and some of the accessories that go along with it. The short version is the lathe is working great. I mean, really great. And, well, let's get started. Let me show you some of the stuff that it does. Yeah, it's kind of hard to get the whole thing in frame. The Glassworking Shop is a pretty small shop, and I can't really back up far enough to get everything in frame. But let me see if I can get a better view. Here is the current version of my prototype glassworking lathe. And actually it's a lot more than just a glassworking lathe. It's what I call the integrated lathe workstation that consists of the lathe itself, the bench that it mounts on, and then a couple of convenient side tables that hold a variety of things. And I kind of think that this, well, first of all, this system is designed for my needs. And, you know, one thing that I've learned in the glassworking world over the years is that there's a wide variety of different approaches, different skills, different techniques, different ways that glassworkers have learned to work with their tools. And, well, this one works for me. And I suspect it may work for others as well. A bit of history. The glassworking lathe was invented by Charles Litton in the 1920s, and it was invented primarily for scientific and electronic use. And over the years, the scientific glassworkers have developed tools, techniques, accessories, procedures, and they're totally used to the way their lathes work. Well, in the artistic world, the stuff wasn't designed for us. It was repurposed. A lot of artistic glassworkers will buy an old scientific lathe and use it in their shop with their techniques and their procedures. What I've kind of found is that a lot of the ideas that seem to work well for scientific, for the work they do, don't seem to work that well for me. And so I came up with a different approach. Try to look at it like, what if I started with a clean sheet of paper and was going to invent something for the first time that's based on a traditional glassworking lathe, but, you know, different in some ways. So let me go over some of the details about why this lathe and its workstation are different. One of the first things that is obvious about the integrated lathe workstation is that there's a lot of space here between the bottom of the lathe bed and the work surface. Many scientific lathes have maybe an inch or two. The large floor model ones have no space because there is no table, it's just a lathe. And I've found that having a fairly good amount of space between the lathe bed and the table is a really useful thing. There's a lot of room for glass rods, for tools, for stuff that you're working on, for just place to put something when you don't have anywhere to put it. So anyway, the space between the base and the table is one of the things about the system that I think is really important. Another thing that you'll probably notice is this lathe has no fire carriage. I realize that in scientific work, the fire carriage is really essential, that people mount cradle burners to the fire carriage and work on very large diameter pieces. In artistic work, Well, we don't use cradle burners that much, and we tend to use different techniques. I mean, it's still glasswork, but artistic glasswork is somewhat different from scientific glasswork. So this lathe has no fire carriage. But what it does have, and let me move the camera here. Yeah, it's kind of difficult doing these videos with no camera operator and having to shoot the video, hold the camera, and narrate at the same time, but hey, I do my best. The lathe has an open section in between the two frame rails, and this is something that is not common in standard traditional glass lathes, but it allows the Bunsen's to be mounted on bearings below the rail and allows them to be moved by grabbing them down where it's cold and not having to get your hand into the heat zone to move the Bunsen's around. Notice that the Bunsen's move very nicely on the same rail system that the tailstock moves on. Now, one of the advantages of this design is that the rail is under the frame so that it's protected from heat and protected from just junk buildup. Glassworking can be pretty messy as little pieces of glass end up landing everywhere, and you don't want to get them into your bearings. And so everything that is even slightly precision or complex is below the surface, and on the top of the surface pretty much is just steel and aluminum. There's nothing here to be damaged, and so it doesn't need a heat shield as a standard traditional lathe would need. Another thing that the system features is the integrated torch Armadillo. This is one of my products that works well in a variety of situations. It's commonly used in traditional glass lathes. It's used on the bench. It's used in a lot of different situations. And the integrated lathe workstation is specifically designed, the geometry is optimized for the use of the torch Armadillo, and I find it to be an extremely useful tool. Once again, there are glass workers who prefer a hand torch and absolutely hate mounted torches. And, that's fine. Once again, everybody has a different opinion. Everybody has a different working style. But to address those who like a hand torch, I'm also working on an experimental prototype here, which is a quick disconnect system. And I'll probably show a still photograph because it's hard to get the detail of this in the video. So I'll just go ahead and show a still photograph. But this experimental prototype is fairly small and minimal, especially on the top, and pretty much allows easy use of the hand torch as a hand torch, and then fairly effortlessly converts to mounted torch when using with the torch Armadillo. Another idea that I don't have a prototype yet, but I'm certainly thinking about it, and probably in the next update I'll be showing it and demonstrating it, is using the torch Armadillo to hold a cradle burner, because even though artistic glassworkers don't use cradle burners a lot, it's still a useful tool. It's still a good thing to have around. So that will be coming in upcoming versions. Another new thing, let me move the camera here and try to get a better view. I've been working on the user interface and control functions for the lathe. This is still a work in progress. I haven't come up with a final solution yet, but there's some things about it that seem very interesting and very useful. It displays speed in RPM, which may or may not have any value, who knows, but sometimes it's nice to be able to just remember, oh, I like doing a particular operation at 40, I like doing a particular operation at 70, so it's kind of nice to have an RPM display. When the lathe is moving, the reverse button will reverse direction, and because the chuck and the workpiece, the chucks and the workpiece have mass, you can't reverse instantly, so the control system has a built-in ramp up and ramp down function to be able to reverse speed without shocking or jerking the system. Now, when it's turned off, let me zoom back out again. When it's off, the knob controls what I call the jog function, which is basically manually moving the chuck, and it displays in degrees what the position of the chuck is. The buttons along the bottom are for programmability. So you can program a move and then execute the move either forward or backwards. So let's say that you wanted to divide up something into 4 pieces. You could program a 90-degree move, and then the chucks would move 90 degrees every time a button is pressed forward or back. Because the lathe has 2 independent motors, one for each axis, it has no drive shaft, it has no sprockets, it has no chain, it has 2 independent motors, and having 2 independent motors allows the possibility of introducing twist. The twist knob on the user interface is a spring-loaded return to center knob, so you're pushing against a spring as you're commanding more and more twist. And it doesn't work very aggressively, but you probably don't want to be super aggressive when doing glass work. I've found it, and it twists forward and backward. I've found it to be very useful and very controllable, and I think it could potentially be a very useful feature. Also, when the lathe is not moving, the twist function continues to function, operating the tailstock motor only. Another feature that I have on the system is an integrated plumbing system that allows the blow hose, the blow tube, to be routed from the headstock to the tailstock, and it also allows vacuum to be applied for operations like vacuum sleeving and vac stacking. So the lever down here turns on the vacuum, and then this is a kind of a standard valve. The tailstock, I don't know if you can see from this shot, there's a copper pipe that goes through the hollow frame and comes out the other end, and that's where the tube attaches. I also made some 3D printed tube supports to keep the tube from kinking. And you may or may not notice by looking at this that the tube is a larger diameter than is traditional for blow tubes. I'm using a 3/8 ID instead of a 1/4 inch ID blow tube. And this is to prevent back pressure when working with a hot, thin bubble. Sometimes the air expanding inside the bubble causes the bubble to basically blow itself. And, you know, sometimes that's not a good thing. And I found that reducing the back pressure by use of a larger diameter blow tube seems to alleviate that problem somewhat. I also, and this is also pretty difficult to see on the video, but let's see if we can maybe look at it. I made a custom adapter that goes from the 3/8 blow tube to typical 1/4-inch fittings with minimum resistance. A lot of the commercially available adapters have very high resistance, and there's no reason for that. It's possible to design one that doesn't work that way. Looking around on this view, you can see the motor and the drive belt. This is a tooth drive belt that provides excellent excellent performance. It doesn't slip, it doesn't develop looseness over time. Headstock is simple ball bearings. The traditional lathes use these really heavy ball bearings that, you know, look like you look up the specifications for them and they're rated for, you know, use on a heavy mining truck with like 60,000 pounds or more of capacity per bearing. And this is a glass lathe. We don't need that. I guess in the past it was traditional to use the very heavy tapered roller bearings, but for this application, this certainly seems to work fine. And then around on the other side, on the headstock side, there's a control box. This is actually not the control box. I didn't really say that correctly. This is the power supply, motor drivers, and other associated electronics. All of the cabling is in conduit to basically protect it against all of the nasty things that may happen in a glassworking shop, and it's all connectorized. I've got a kind of a flimsy, adjustable El Cheapo Chinese flexible arm on the control panel. This is not part of the final design, but it's a very useful for prototype testing to be able to position the controller in a convenient place. And then eventually, as the design is finalized, I'll pick a place I like and then just have it like solid in place, because the adjustable one isn't really that good, but it's good enough for testing purposes. This little moving table is set up with a bunch of stuff on it. It's got a gas manifold. It has one of those valvey things that you can hang a hand torch on. It's got regulators for torches that don't like full pressure. It's got a place to store my quick disconnect blow tube when I'm not using it. And on the other side is a similar little rolling table. This is all made out of steel. The little shelf surface is stainless steel, so heat doesn't bother it. It's got a water bucket, which is necessary in glasswork, and then the variety of tools. Overall, my working philosophy is keep the area as clean and well organized as possible, and tools that aren't being used right now should not be in the work area, should not be getting in your way. So the tools on the top are pretty convenient to just grab, but they can also, if you're in the process of using a tool frequently, it can also be stationed on the table surface. And I find that this arrangement works very well. I also, get down here, I make my own manifolds. I'm a machinist. I have a machine shop. I could easily make a solid aluminum manifold like the ones that are commonly sold, but I kind of like to use just regular brass pipes, plumbing fittings, because it's easily configurable, it's reconfigurable. If I change my mind, I can unscrew and move it around, make something new, and they seem to work exceptionally well. This is a switching arrangement with a foot pedal and a couple of solenoid valves, high quality solenoid valves, ASCO red hats, that are used to control the flame on the Mirage. In the tool rack, I have a number of prototype tools that I'm experimenting with that, who knows, may or may not go into production. I may work with other tool makers to see if I can get somebody else to make them if I don't feel like making them. I'm not going to include them in this video because this video really is all about the lathe, but I've been working on a lot of different ideas for tools, different types of tools, and it's nice to be able to have a machine shop and just when I have an idea, when I need a tool, just go out and make it, see if it works. This is an experiment that I am working on, an idea to have a bar that, let me see if I can pull the thing out and show how it clamps into place with a pin and moves out of the way. Haven't really found a use for it yet, but there's always the possibility that some sort of tool or steady rest or some other kind of a thing could be included. And once again, this is an engineering prototype where I'm testing out a wide variety of ideas. So the question might arise, what comes next? Well, my main motivation for doing this is I'm a maker, I like making things, I'm a glass worker, and it's a cool toy for me. But the question often arises, will it ever be offered for sale? And I don't know the answer yet, but here's the various different considerations that need to be addressed. First of all, it's really hard to make in my shop. It was almost impossible to make in my shop, and I really don't want to make another one because I don't really have the appropriate machines. I have machines, obviously I could make it, but it wasn't fast or efficient or easy. And so it would really require a shop that has machines that are more suited to this kind of manufacturing. And yes, I am talking to at least one shop owner, I think possibly even two, who have machines that are more suited for this kind of work. The next question, of course, is there a market for it? As pretty much anybody in the glass world knows, times are tough in the glass world. Sales are down, and just the economy in general, everything's getting more expensive. The first thing to be eliminated from most people's budgets is glass art. I mean, you know, art is a luxury and not everybody can afford it. So the glass market is down. Used lathes are abundant. The old lit and cast iron lathes, they last forever. You pretty much can't kill them, and they're abundantly available as glass workers kind of, suffer from the economy of the times and are forced to sell their equipment. And so really the question is, what would it cost to make these things? What could it be sold for? Is there a market for it? I don't know. I would be very interested, anybody who wants to comment on this, I'd be very interested in comments. I'm very interested in working with other glass workers to get opinions on this. So anybody that kind of wants to come to the shop and try it out, just contact me and see if we can work something out. Because in my opinion, And of course, I'm not a master lathe worker, but I do have a bit of lathe working experience. But in my opinion, it's great. Works better than my Litton. I'm pretty much completely happy with it in every way, but, you know, could it be a commercial product? I don't know. Anyway, that's all I have for you. So thank you for watching. It's been fun.